Okay, ladies and gentlemen, let me introduce you guys the indeterminate family. And yes, they are actually on my shirt already, but of course, I will write it down right here for you guys. First of all, let me introduce you guys the parents. We have 0 over 0 and infinity over infinity. But I don't know which one is the mom, which one is the dad. You guys can let me know. And then, let me tell you, we have 5 kids. Let me write down the first one, 0 to the 0th power. And then we have infinity to the 0th power. And then 1 to the infinity's power. And 0 times infinity. And lastly, infinity minus infinity. And this right here are what we call the indeterminate forms when we are calculating limits in calculus. And the idea is that if you are doing a limit question in calculus, and if you run into one of these forms right here, congratulations, you have to do more work in order to figure out what the answer actually is. And in this video, I would like to just talk about 1 to the infinity's power, because this one right here, it's like the badly behaved kid. Because it caused so many misconceptions. A lot of the students would just think about, hey, isn't 1 to any power just 1? Then why couldn't we just say 1 to the infinity's power just equal to 1 then? Well, here is the deal. Again, this right here are what we call the indeterminate forms when we are calculating limits. And when you see this one right here, I hate to break the news to you guys, but this one right here is actually not exactly equal to 1. This right here, it can be like 1.000001 or 0.9999999. It's just a number that's approaching 1, and we put on 1 as the form, right? And when you have 1.00001, for example, and then raise that to a big number, I would say, you actually don't know what it will be unless you do more work. However, before we do any of the calculus, let me just tell you, don't get me wrong though, if the base is exactly equal to 1, then we can be a lot happier. And let me put that down right here for you guys. This right here is, unfortunately, the happy case that we don't really get. Yeah, I know. But again, I'll write this down right here for you guys. If the base is exactly equal to 1, right? Exactly equal to 1. Well, then you can get 1 to the 12th power. This is, of course, 1. If you have 1 to the 200,000, well, you can put on 2 more. Well, this is going to be, let's see, 2 million. 1 to the 2 million, this is still equal to 1. And of course, you can do whatever you want. 1 to the pi, this right here will be 1 as well, and a lot more. But please don't say anything with complex numbers. Anyway, in this case, if you do have an exact 1 for the base, and then you raise that to an infinity power, this right here, you actually will be 1. But the deal is that if you're just talking about solid numbers, you cannot really put on infinity, because the moment you put on infinity, you're talking about limits. So this right here is kind of not that great of an example, but the idea is if you do have a solid 1 raised to a big number, raised to anything, you will get 1. But here, again, this form is not exact 1. So that's the main difference. That's the main difference. And now I will show you guys an example of a limit with the indeterminate form, 1 to the infinity's power. And the answer for that limit, we don't get 1. And before I do that, I would like to recall this right here is the compound interest formula. And I believe a lot of you guys have seen this formula back in your pre-calculus class. And the idea is that this is the formula that we use to calculate compound interest when we compound n times in a year. And notice we have the n right here and right here. And from this formula, I would like to just talk about a function right here. Let me just write down, we are going to consider the function f of x being 1 plus 1 over x raised to the x power. And this right here is saying we take the principal to be 1. That means we have $1 to start. And then the r is 1. That means we have 100% interest rate, which is really good. And then t is 1. That means we have 1 year. And then I will show you guys a table of values. Well, first of all, let me pick x to be 100. And in this case, remember, x is the n, meaning that we pretty much are compounding however many times in the year. If you say x is 100, that means you compound 100 times in a year. Well, when you put 100 in here, first of all, you just work this out. You get 1 plus 1 over 100, and then raised to the 100's power. And when you work this out, this right here is 1.01, and then you take that raised to the 100's power, like that. And I will tell you guys what the answer is. You can use a calculator to do it. You will end up with 2.70481, like that. And of course, you actually have a lot more after that, but I'll just write down the first few digits for you guys. Next, I'm going to start increasing the x value to, let's say, 10,000. Well, you pretty much do the same thing, and let's do this in our head. When you put 10,000 into this x, you do 1 plus 1 over that, you will end up with 1.3 zeros, okay? 3 zeros right here, and then 1, and then raised to the 10,000's power. Let me just put that down right here. And the answer to this, after you use the calculator, you end up with 2.71814, and so on after that. And I will do it again. I'm going to increase the x value to 1 million. Let's say 1 with 6 zeros after that. And when you put this right here, you will get 1 point with 5 zeros right here. 1, 2, 3, 4, 5, and then 1. And then, of course, you take this raised to the 1 million's power, like that. And here's the deal. Notice that earlier, I put down 1 to the 2 million is 1. Well, this right here, the base was a solid 1. This time, the base is no longer solid 1. It's 1.000001. When you take this raised to a 1 million power, of course, you can work out this on your calculator. You get 2.71828, and so on. And you can start to imagine that if you keep increasing the x value, well, the values right here, it's going to be about 2.71828, and so on. I'm going to leave that to you guys, but you guys can see these values are approaching to a really special number. So I will just put down ... and then right here I also put down ... This right here, so far they are just regular computation, but if you want to find out the limit of this function, when x goes to infinity, of course in the end we have to consider infinity right here. And in this case, in fact, we write this down. Of course, in calculus, whenever you put this down, you have to talk about the limit. Again, earlier I put down the infinity here. It's technically saying the limit as x approaching infinity of a solid number 1 raised to the x power. This is just solid 1 to the x power. That's what it means. Whenever you see the symbol and then you end up with 1, that's legit. But in this case, when we have the infinity, of course you are going to write down the lim for infinity, for the limit, and then you put down x going to infinity, and then of course 1 plus 1 over x raised to the x power, like that. Well, as you can see, we do have a number that's not equal to 1. This right here is actually a special number. We call this number to be e, and this right here is approximately 2.718281828 and something. I know what you guys are going to say. It seems like we just have 18281828 repeating, but the truth is no. The truth is you have 4, 5, 9, and then a lot more after that. This number has been proven to be irrational, meaning that there's no pattern in these numbers right here. So here is the deal. If you're trying to calculate this limit, usually what people do is we first put whatever this is into this x and that x, and it will seem like 1 plus 1 over infinity and then raised to the infinity's power, right? And in this case, 1 divided by infinity, in fact, we can draw a conclusion. we can say this right here is approaching 0. And notice how I changed the arrow right here instead of the equal sign. Inside out, we'll get 1 plus this becomes 0. And then the outside will still have the infinity's power. And then again, when you do 1 plus 0, we can draw conclusion. It's just 1. So people will just put on 1 like that. And then on the outside, you have infinity's power. Well, as you can see, if you just put the infinity into here and here, you will end up with 1 to the infinity's power indeterminate form. And you have to keep in mind, you are doing limit. The base right here is unfortunately not a solid one, unlike this right here. Technically, again, they are just like limits as well, but as I said, if the base is solid 1, you will end up with 1. But unfortunately, the base right here, this wasn't a solid one, it's like this. And people just put this down. I would say it's like for convenience. Again, this right here, this is not exactly 1. Okay? That's one of the indeterminate forms right here. And as you can see, this right here turns out to be E. And you cannot really prove it because this is again a definition of E. So you just take this. But I will tell you guys a few things though. Okay, so before we go, I just want to tell you guys about Boolean.work. First, I want to thank them for sponsoring this video. And now they have this new daily problems, which features a lot of interesting questions in math, science, engineering, physics, logic, and all that. You guys will find it really interesting. And I found a lot of interesting questions to solve. And in fact, I wanted to show you guys this one right here. Because on the other day, I was teaching how to find the volume of a donut to my calculus students. And they actually have these questions right here, which is really cool. And you see that we have a picture of the donut. Yum, right? And the question is, which of the following can be formed by taking a cross-section of a donut? Here we'll make horizontally and all that. Is it possible to get all of this or just some of this and all that? And you can also cut the donut like slanted, all that. And if you enjoying this question, be sure you guys come here and check out more. And you guys will really like these questions. I really like the way that I set up the questions because you can do a lot more and you can see explanations if you're stuck in one of the questions. And also go check out their community page. You will find a lot of people who like to just talk about math. I know a lot of you guys like to talk about math, and you can find a lot more people right here as well. Signing up is free, and if you use the link brilliant.work/blackpenredpen, you can get 20% off to their annual premium subscription. Be sure you guys go check them out. Thank you guys so much. So now let's take a look at 3 more limits. And if you plug infinity into all these x right here, you will end up with 1 to the infinity's power indeterminate form for everybody. But I will tell you guys that you end up with different answers for these questions. And I will leave the verification on your own. You guys can just do a table of values like what we did earlier. And I'm going to leave that to you guys. But let me tell you guys that the answer to the first one is you get a nice number 4. Alright? And then the answer to the second one, and yes, this is in the form of 1 to the infinity's indeterminate form. And you end up with the one that people like. And lastly, if you put infinity into here and here, and yes, this is again 1 to the infinity's power indeterminate form, but the answer to this limit is infinity. Right? So they all have different answers, even though when you have 1 to the infinity indeterminate forms. So the conclusion is that when you are calculating limits, when you have 1 to the infinity's power, again, we don't know what the answer is unless we do more work. Because the trouble is, this one here is not, I shouldn't draw the arrow anymore, this is not a solid one, well, not exactly equal to 1. Maybe like hashtag not exact 1. So that's the conclusion, alright? So that's it for the video, and thank you guys so much for watching. If you guys have any questions, just leave a comment down below and let me know. And as always, that's it.